We're an Amazon and Public partner, and we've been integrating these two products together for about 4 or so years now. We want to just explore 5 key solutions which we've deployed to relative clients sort of around the country. We're just going to step through these designs. The first 2 are kind of pretty quick. Just by show of hands, really quickly, who has Puppet in Amazon at the moment, right now? A few. Who wants to put Puppet in Amazon in the next 12 months? Quite a few more. Okay, cool. All right, so just very first, we're just going to do a little bit of a review. So this is basically solution 1. So our first presented architecture was from a financial services customer. They had an extremely large global infrastructure footprint that was pre-existing. They had heavy requirements around compliance and risk management. And whilst this solution wasn't specifically on AWS, there's lots of concepts that we deployed here which are very relevant to our AWS journey, which is why we're going to present it here. So as with most first deployments of Puppet, they had a very humble goal of tailoring their operating systems to be suitable candidates for the applications on which they wanted to deploy. They also wanted to ensure compliance against those standards, with the intention being overall to converge their infrastructure and application configuration into a single platform. So I think this is a very common goal that most people share when they move to Puppet. And obviously out of the back of that, we get all these really good business features like auditing and governance and control. So enterprises really leverage this capability to review and report on the lifecycle objectives and lifecycle of their applications within their enterprise, right? And really, it comes back to governance with a lot of enterprises. So we heard Renee talking about the use of Puppet to maintain SOE standards and security standards. I mean, that's a very, very well told story across a lot of enterprises. And a lot of Puppet has to do with compliance. So the very first solution that was deployed is we basically, as it was a business critical solution, we deployed a globally distributed multi-master setup whereby we had Puppet masters in each specific global region, all talking back to a centralized Puppet master. So he was just making the platform more robust, obviously. There was another sort of key feature they got out of this though, is that these different regions had different out of hours time blocks. So there was a further reduction in deployment risk from these organizations, because not only did they have to follow the typical dev, testing, UAT lifecycle, but if they were to push out a production patch in one region, they could actually kind of stop it and pause it before it actually got globally distributed if they detected a problem. So the multi-master, talking about the single master setup, was kind of a key feature there. So from this, this solution was actually presented back in Puppet Camp in 2012 by Greg Coburn. So anyone who's interested, and for those playing the home game, this is where we can get the slide deck for anyone who's interested in that solution. So the next solution we want to present, so that was solution 1, was basically globally distributed Puppet masters. Solution 2 we wanted to discuss was a client where we had the unique opportunity that they were going cloud native from day 1. So they didn't have any physical infrastructure to worry about. It was unique at the time. This was before AWS Sydney even existed. This is back in the dark ages of Singapore. But basically they'd made the decision to go completely cloud native on day 1. So this represented a really unique opportunity for us to kind of adopt 2 things that we get by using cloud services. And the first key thing we get out of using cloud is that everything's programmatic. So for us, deploying infrastructure and storage and network was just an API call away, right, which is a fundamental difference. And the other thing is that the resources and compute infrastructure we're getting was highly standardized. So James is just going to quick talk about what we did with this.
Sorry, can anyone hear me at the back? Excellent. So obviously Puppet knew about this, the standardization of compute resources and the programmatic access that was available from some of these cloud providers. They already had a native AWS module called Cloud that was able to interface directly and provision with AWS and provision and deprovision EC2 instances, along with classifying them as part of the Puppet dashboard with the groups to used as an ENC to also push down configuration to the machines as they're provisioned. I suppose a limitation of this, around a similar time frame, AWS had then launched VPCs. VPCs were a fundamental change to the AWS sort of security model. So rather than an instance being globally available just through EC2 Classic, Amazon VPCs allowed enterprise customers to effectively extend their data center or private IP space into Amazon Cloud. It was an isolated network of sorts. I suppose In terms of connectivity, there's options like VPN and Direct Connect, and that allows that interface to effectively unlimited amount of resources to be deployed into an enterprise data center. So building on the Cloud Pack module available for Puppet Labs, Source Group, as part of the PuppetConf 2012 presentation that John Spinks presented, we looked to re-engineer the module to be able to support AWS VPC, or deploying in AWS VPC. So obviously there's, if anyone here has worked with AWS VPCs before, it's not as simple as just clicking your button to EC2. There's a lot of moving components of VPCs, things like security groups, routing tables, correct subnets, and the like. So the uplift to the code base was to enable provisioning into this framework. To further hedge risk for the enterprise deployments that we were looking at the time, we also extended the Cloud Pack to support multi-cloud provisioning. So in this case, we were looking at Rackspace and Joint. So available from one single Puppet face, we could then deploy to Amazon Web Service, Rackspace and Joint. And then utilising the Puppet framework over the top of this, it allowed customers to manage the application regardless of the underlying infrastructure. So you can still provision machines in a programmatic fashion, and then manage applications and OS configuration sitting on top of each of these providers. Anything on there?
So I guess the concept we came away with there was that the first two solutions were primarily targeted at tuning specific compute resources, whether it be physical or virtual, to match the application workload requirements. And we're facilitating that through Puppet being that standardization layer. So whether it's physical or cloud, whatever, Puppet would standardize the compute platform for you, and you just drop your app on there. So this is a pretty common use case that everyone's talking, or everyone uses, I think. So it shouldn't require too much explanation. So we then moved on to a slightly different engagement, where not only did this client have a specific, not only was this client going purely cloud native, but they also had a very strong requirement to support Amazon things like auto-scaling and transient compute and all that kind of stuff. So just before I dive specifically into the details of one of the solutions, so this is the third solution we want to present, I just want to review very quickly why cloud computing was fundamentally different, not from our perspective, but from what the business saw out of this. So the key concept that I think out of cloud computing is everything's transient. Everything is transient at this point. So it's not just both service availability in terms of auto-scaling and auto-healing, that kind of stuff, but it's also transient in terms of the lifecycle objectives of applications. So as we heard before, and through some of the other presentations today, people are no longer having a server that they're trying to manage over and over and over again, right? Instead of copying the risk that's involved with updating a server, they much prefer just to deploy a whole new brand set of servers completely from scratch, because it's now a really trivial process, right? And then to migrate the traffic onto those servers. So this fundamentally changes the way we handle and manage infrastructure. So the first part out of that is our infrastructure deployment configuration standardized, right? And it's not standardized in terms of we've written some Puppet code, it's standardized in terms of the resources we're getting from these cloud providers are standard by their own definition. And it's not just the servers that were transient, but it was the entire application stack. So we had to use tools that understood the entire application stack, like storage and networking and all that kind of stuff. The second effect this had, like I showed, is it fundamentally changed the application lifecycle within the businesses. So enterprises were very quick, or I think a lot of enterprises are very quick to leverage this agility to drive their application harder. They wanted to iterate even harder because they can, because there's very little process involved now to roll out a new version of our application. So while we're seeing updates and infrastructure that was on a weekly or monthly update process, we're now talking about hourly updates, or the golden term that everyone wants to talk about, continuous delivery, right? But there's so much to that topic that is just skimming the surface. Really quickly, just as a 101, the reason we were able to achieve this agility in deploying applications is because we were using tool sets that understood what the application lifecycle was, right? And that's a fundamental difference. Is tools like Bamboo, which is typically a development tool, and a tool where they integrate code and get a commit and branch that commit and have 15 branches all running simultaneously all at the same time. Bamboo knew that lifecycle process and it knew how to manage it. So if we start plugging in Amazon stuff into the back of that, we now get Amazon application stacks for every single commit, for every single branch, for every single application. All right. Don't really want to go through this a lot. Renee covered a little bit of this in this slide as well. Anyone who's interested, there's a really good Amazon user group that runs every month or so, and a lot of this kind of content's in there. So if anyone's interested in how to click a button and get a data center or an application delivered in Amazon, then that's the user group for you. So the key point here is that we started to drive not just the applications and the servers harder, but we started to drive the stacks harder. So we don't touch the servers anymore. We don't have Puppet manage the servers. We have other tools just roll out entire copies of our application all at once, right? So Nigel said this morning that 18 months really sucks. Every single product manager for all of time has always said that, right? So this is where the business impetus came from. The second change we really saw is that business teams are willing to accept standardization of the compute platforms and accept rigid frameworks to fit within if they gained agility and they gained control. So instead of us trying to shape the operating systems to suit an application, now we could provide standardized containers, right? Inform the business of what those standardized containers look like and what they had to comply with, and they could just drop their app in there and they know it would run successfully every single time. So this led to this colossal explosion of applications running. I'm talking here, this is a very, very simplified view, but because the business users could just drop their app into a container and have it run without having to worry about it, and because they were willing to invest in making the app run within that container, the byproduct of that is there's just apps going absolutely everywhere, right? Because the other byproduct of that is using CD and all the other stuff we were talking about before, these apps were being refreshed on an hourly basis. So every single one of these little boxes is being ripped down, redeployed every hour, right? So the three sort of key fundamentals that Puppet was managing for us, right, actually really changed, or in my mind they really changed. Application configuration and configuration management was being handled incredibly well with the application-aware tools like Bamboo and all those other tool sets and CD tool sets, right? However, we now have boxes going absolutely everywhere, and we now have SOEs going everywhere, and our compliance has gone through the roof. So our priorities have changed, right? We now have servers flying around, all around these clouds that we have to provide the governance, and that's what Puppet does best. So the end result of this is that we still need Puppet in this solution, and we want to present the solution now that we're going to use to do that. So there's another key feature that the businesses want to use, which I'll flick to James.
Thanks. So obviously having a lot of stacks sitting around, you don't want those to be static in nature. So think you're doing performance testing or even production workloads. So looking at sort of a graph over here of load on time. So think your peak traffic could be 12 p.m. On a specific application itself. Traditionally with static stacks or teams in a data center, you need to cater for that maximum peak in utilization. And whenever the load is sitting below that, that's effectively underutilized kit, right? So it's wasting money, it's wasting costs. Auto-scaling groups, or auto-scaling in general, a key feature of AWS EC2 compute platform is a feature that we've utilized, and I suppose I'll move in towards the demo and just give a little bit more context. That is able to dynamically scale the compute resources, to quite closely follow these this graph in terms of load versus time, right? And it's essentially matching demand with the cost. So it's saving costs for our customers. So as you can see here, traditionally, in a data center, traditional tin or even static stacks, you need to be catering for this peak load here. By dynamically using auto-scaling, you're able to save money and for the business itself. Now, so the key concepts of auto-scaling is the auto-scale mechanism itself. So it's been able to define correct metrics for the application that and a specific rule set to either scale out or retract the amount of compute that's been used for the platform at a certain point in time. There's also the concept of self-healing. So based on certain health metrics defined for applications, you're able to revision not repair, which is also another key advantage for the operational teams that some of these businesses have in managing these platforms.
Right. So essentially what we aim to do here is we aim to articulate what we believed or what we saw as some of the problems that were coming out of trying to put Puppet into the cloud and trying to have Puppet manage instances that are running in the cloud. So as we've heard with some of the other presentations, right, a lot of people get a Puppet master and they get some CloudFormation or whatever, and they run these stacks up in the cloud, and then they turn auto sign on, right? And then have all these nodes like hammering into Puppet, and they're all signing themselves, and that's really great, and they're getting all the compliance. But then we have this really big problem is that, whether it be auto scaling or whether it be stack destruction or whether it be an application role, we end up with all these assets that are like lying around everywhere. So, who's had that problem? Who's recognized that problem, right? Okay. So the problem really is that the Puppet in its current iteration wasn't aware of Amazon and wasn't aware of some of these changes in the underlying compute platforms that were running. So going back to the solution 3, I believe we're up to now. So solution 3 is the massless Puppet, right, that a number of people have adopted. So the massless Puppet was all about basically getting the same level of governance and compliance out of Puppet, not necessarily for the applications, but for things like the SOEs. The SOEs are globally distributed thing, users are globally distributed. The application deployment was being handled via CFInit and via Amazon native tools, but Puppet was still, had a huge part to play in that governance and SOE compliance. So we essentially got rid of the masters, and we had instances checking in against Amazon S3, which is obviously essentially an infinitely scalable file store platform. And each of those instances would pull manifest from S3 and update themselves, and they'd run that cycle completely independently. So we could have the instances scale out and have 300-400 of them, or we could scale it back and only have 10 of them. We didn't care, like it wasn't impacting our Puppet masters, it wasn't polluting our dashboards, anything like that. So this was a very high level view of one of the solutions. So this is essentially solution 3, was getting the masters out of the way and using Amazon S3 as essentially a file store instead of having Puppet. Of course, we still want that compliance, so all of the logging and all the Puppet data, all the Puppet logs are still being fired into your centralized logging platform, like Splunk or Loggly or any one of those products, so that you can get those compliance dashboards and so you can report on what's changed. However, we have a solution 4. So solution 4 is that Kieran, sorry, I don't know why I keep calling Kieran. Nigel comes out with like big statements like this, right? And we realise that actually the way that Puppet's going is that we actually need the masters back in place. So.
Yeah, definitely. So, having the masters in place, especially use of Puppet DB, allows for the cross-pollination of data. So, making nodes aware of other nodes, that's probably one of the key functionalities that we lose by looking to scale using AWS S3 as the sort of the manifest store for these deployments. There's also, for some of our clients that are security conscious, there's the fact that using AWS S3 rather than using Puppet masters themselves, agents are able to get their hands on a lot more of configuration. So there's actually cross-pollination between different stacks, application stacks that shouldn't really know about each other. In general, when a Puppet master does a deployment, it starts managing configuration on an agent. A cut-down version of the catalog is compiled specifically for that machine. Yes, I'll just hand over John for the...
So we see another really, really big reason why we need to have the masters, right? And this is one that I think a lot of enterprises deal with. And this is this question. So a lot of people have incredibly large install bases of Puppet already against their data centers or whatnot, and they just want to flick that across to Amazon. It's not that easy, right? Because all the business users want automatic updating stacks and auto scale and all this other goodness here, but we've got this huge inbuilt base that's still over there. So essentially, I think the hybrid cloud was the second huge driver that forced us to look at the masters and say, how do we make these masters, more cloud aware? How do we make them more aware of Amazon and how Amazon wants to manage their infrastructure? And how do we plug into the native features of Amazon, like their really strong orchestration, their really strong monitoring, and more importantly, their scaling. Amazon does an incredibly good job of scaling applications automatically, and we need Puppet to know about that, right?
So obviously, as John alluded to, we really need to uplift the Puppet framework to understand and deeply interact with the Amazon Web Services themselves. So we really wanted to make sure Amazon was doing what it does best. That's scaling, some orchestration, monitoring, and sorry, yeah. So we wanted to really look at that. So as part of the demo that we're going to do today, it's a Puppet AWS auto scaling broker. So what we've looked to do is, by tightly coupling Puppet and the AWS APIs, we're actually able to notice when auto-scale groups, so on a scale-up event or a scale-down event, we can notice when when an instance is provisioned or deprovisioned. The third thing of that is we're able to let the Puppet framework know that a certificate is either available to be signed and then also classified, or on a termination event for an auto-scaling group, we can feed that back into the Puppet framework and revoke certificates, deactivate nodes in Puppet DB, and also clean out the Puppet console to really manage this deletion of inactive resources. So the main components that run up this solution that we have here for automation is our Amazon SQL notification service. That is effectively or natively ties in with Amazon auto-scaling groups to provide alerts with different actions that get taken on instances that are part of an auto-scale group. Sending that alert through to an SMS topic that's able to be stored in Amazon SQS or SQL queue service. So that's a highly scalable, redundant, and guaranteed message framework. Persistent framework. And then, so our broker effectively polls these for the messages. So we're looking for these events to happen in auto-scale groups and in these different environments. And then we can orchestrate, signing of nodes and also cleaning up of these resources.
So what I'm going to do is we've basically got some auto-scale groups set up. So typically you'd be responding to events, such as what AutoScout does is essentially responds to alerts from CloudWatch, which is a monitoring platform. So if you had 10 web servers behind a load balancer, it would average out the CPU of those 10 web servers, and it'd essentially say, all my web servers have reached 75% busy on the CPU, I need more capacity, I need more compute power. So we've got some basically AutoScout groups. Normally this is 100% automated, so auto-scaling itself is polling the metrics and scaling in and scaling out. Right now I'm just going to force one of the groups to grow. Actually, first thing I'm going to do is actually force one of the groups to shrink, because it's a little bit quicker. So I'm just going to shrink one of the groups now. We should see it come through.
Cool. Yeah, so guys, so for visibility, this is just effectively a log of the automation piece that we've pulled together. And in the background here, you can see the Puppet console that's already got a bunch of nodes from different auto-scale groups already registered. And some of them are classified, as you can see in the groups over here, ASG1, ASG2, ASG3. A key feature of the Amazon service that we did use in terms of doing node classification was the use of EC2 tags. So through the use of EC2 tags and CloudFormation, we're able to set the class of the node or the group that we should be adhering to on the Puppet console and automate that piece using the broker. So I'll run back to a slide in a second, but as part of a launch event, the broker monitoring the queue will receive that message of the launch event. It'll then go and programmatically, you'll programmatically query the Amazon API, retrieve the tags for that instance, and then classify instances based on that information. So as you can see now, John's just forced the scale down event on one of the auto scale groups, so that results in some termination messages being sent into SQS. You can see the broker picking these events up. And it's also revoking the certificate, cleaning the reports out of the console. So realistically, with the dynamic compute platform, if we're looking at the healthiness of how healthy resources are, how healthy an autoscale group is, we really want to see only the relevant compute resources. We don't want to see the ones that have been destroyed. We want to clean those artifacts out.
Just on the back of that, so one of the key things here is that because we're destroying the reporting, it is important if your enterprise wants to maintain the history of what's happened on the entire fleet, that the public logs are being shoveled off host into whatever logging and or big data stories you care to use. So we are actually cleaning, completely irrevocably destroying that instance from Puppet. So they should be cleaned up now, James. So, win live demo works.
Okay, so I think was there 2 machines left on in another group?
Yep.
Yeah, cool.
So we're going to do the inverse now. So obviously we want to grow the groups, so as if we were responding to a growth event. The trick is here that we have to stall for time. The trick is here is that, so while that's scaling out, I bring up the logs, cool. That's right. So one of the things that we're very careful to warn enterprises of when we're using this broker is that autoscale is normally giving you compute resources because you either need them, or you're in trouble, or you're trying to heal an application or something like that. What's actually happening here is that we've basically used a very similar technique to like what Renee was using with having like a baked AMI. So we have a baked AMI that just has the Puppet agent already installed. It just cuts sort of 2 minutes off the install time. But basically, this AMI is being launched. It's already got the Puppet agent installed, and it's automatically going and registering using all the CF init and Cloud Pack and all that kind of stuff we were talking about before. It's launching and registering itself against Puppet. The thing we want to, I guess, touch on here is that it does take time, right? Like Puppet, and we can talk about this, but it takes time for the node to come in, to launch, for the agent to register, for the cert to be signed, for the Puppet run to happen to make sure it's compliant. So it's important that most of our applications, we still leverage our continuous delivery tool to get the application on the servers, and we're just using this again as the governance and control platform. So having the application pre-installed, then we also have the application defined in Puppet so that the application is compliant once the box is running. But you can see, obviously, there's kind of like a 2-minute delay. Some people can't accept that delay. Some people need the resource like right now, if you know what I mean. So we're launching, I think, autoscaling about 6 or 7 instances out right now. Again, that would have happened automatically by Amazon. And you can see that the groups are being assigned via the tag that's on the instance. So they're coming in, right? So live demo works. So we'll let that run in the background for like 2 or 3 minutes, I guess. No, hang on, one more thing. So the other real cool part about this is that obviously we've built this little broker that's now natively plugged into Amazon. It understands autoscaling, it understands Puppet, so it understands how to manage autoscaling for Puppet. The other cool thing we can do, right, is we've got logging. So we can build dashboards around how autoscale groups are handling and what they're doing. So this is just purely grabbing the logs that have just come out of the autoscaling broker. So it's tracked how many launch events, how many terminate events, given us a rough log and given us a bit of histogram. Now, there's so many more things you can do on this dashboard, but just as a high-level example, that we've now got BI reporting on what your autoscale groups are doing, via the Puppet broker as well. That's the end of demo. Cool. So that was all. It was a pretty seismic shift. Well, not a seismic shift, but obviously we've spent a lot of time interacting with Amazon. We've spent a lot of time interacting with Puppet, and we believe that it's a deep integration between those 2 APIs that makes this kind of stuff possible. And what are the services? So do you want to articulate the services we're interfacing against there? Obviously extending Puppet.
Yeah, definitely. So as part of the broker automation piece, we're leveraging multiple Puppet APIs. So it's things like the REST API, Puppet faces itself, and the Rake API for some of the older dashboard pieces and components. But yeah, as John said, the key pieces there is letting AWS do the heavy lifting in this piece and actually notifying the Puppet framework. So rather than the framework Puppet framework constantly scouring autoscale groups and the environments to see what's going on, we're letting Puppet react in a dynamic nature based on feedback from the autoscale groups or the cloud provider itself.
Okay. Just put this over here. Just to prove to you guys that worked. So there are the instances, obviously, that scaling group is fired off, instances come in. Again, like I said, there's delay. It takes time for the instance to register and for the first run to occur. So once again, you have your application pre-staged on the node, and you use this as a compliance engine. The main thing here, so I guess if we go back and review what we were talking about, is we've now made Puppet aware of Amazon and how to manage Amazon. So we now get all those cool features. We now get Puppet DB, which everyone should be using, and we now get Hero, which everyone should be using. All the other stuff that Puppet are innovating on, and more importantly, that Puppet DB will span your physical data centers and your Amazon clouds or whatever other cloud it is you care to use. Right? So that completes solution 4. So solution 5. So solution 5, I think those first 4 solutions have still maintained a relatively traditional view on how we deploy applications within enterprise. However, we believe that there's something of a seismic shift happening right now as to how applications live within enterprise lifecycle. So what we were talking about before is the first thing that most people do is they want to try and consolidate the control of their operating systems and their application environments, and that tool is Puppet. So we use Puppet to consolidate our operating systems and to tune those operating systems to match our application workflow. Right? The second evolution, which we showed in some of the later solutions, is that if we give a business unit or we give a team a standardized framework in which to place their application, right, whereby the configuration management application configuration is a lesser priority over governance, right, then they will adopt that like wholesale. People will just drop applications in there all day long and let them grow out. And Puppet is really like a key piece because it's moderating both of those frameworks. Okay. So we also saw that Puppet made the applications good citizens of that standardized framework because we control that application. Okay. But we think there's like a slightly larger play as well.
Yeah, so definitely as John touched on, we're definitely seeing a trend with some of our enterprise engagements where there's a move from, rather than tailoring the OS and the hardware to a specific application needs, there's a big focus on the development of applications to fit a standardized framework. So really, instead of tuned OS for an application, we're seeing tuned applications for standardized compute platforms. Now, focusing on development as well, part of featuring this, but so with cloud providers at the moment, we've seen Puppet integrate sort of at the IaaS layer, so infrastructure as a service, being able to procure standardized forms of hardware, so think just via Amazon as well. Puppet then was able to do that convergence piece at the operating system level, along with the application configuration. So that's about where the standardization level was sitting. And then what we're seeing now is there's a really, really strong push to drive efficiency through developers and through the business teams to move this line up to the next level. So this is where runtimes are now being standardized. So it's the big push to get these applications to a standardized state where they can be dropped specifically onto a runtime or standardized runtime compute framework. It drives design for failure applications rather than looking at really HA and expensive hardware that baselines or forms the basis of these deployments. And it also drives the application to be portable. So it's not just a single custom runtime compute framework that can be deployed. There's things like OpenShift, Azure Pack websites, for example, many different PaaS frameworks that once you've got your application to a point where it's standardizing and fit into these predefined holes, as you would, you're able to, the business is able to hedge availability concerns between multiple cloud providers. It also takes, by moving to this level, customers can also take advantage of things like self-heal, auto-scale, which is sort of the nature of transient compute. I suppose one good anecdotal piece of evidence of the big push towards this, and the reason why is one of our slides we saw a team of devs that were on an instance, on a Linux instance. Obviously, they didn't have a great deal of experience on how to develop on Linux machines. They actually deployed all of their code into /dev, so as everyone knows, that's a transient file system. As part of these environments, we actually patched these machines mandatory, right? So it's a security compliance piece. So halfway through the month, we get a phone call, the app's down, it's all broken, what's going on? What had happened is the machine had been rebooted and /dev's cleaned out, so all the applications, the code's gone, lost all that hard work for the last month or so, right? It's a good one.
It's not funny, guys.
No, never say that. So, pushing towards this standardized runtime environment, we get to the point where these application stacks are simply receptacles for application artifacts. The developers don't have a choice where your code goes to. Developers have to sit and fit in with the standardized piece of framework.
Cool. So I guess we don't want to obviously take the focus on Puppet, but just a key example of this would be a platform like OpenShift from RHEL. So essentially what OpenShift does is you deploy a very, very prescriptive and standardized application onto EC2 instances. You can then drop your application artifacts into the said containers, and it will scale it, manage it, back it up, I think. Well, maybe not back it up, but it will take care of all of the operational tasks that you need to do, right? So when you give people these platforms, the feedback starts to become this kind of stuff, right? Like 18 months suck, now 1 week suck, because they just want to drop their app in over and over and over again. So James, just quickly, because we're at 2 minutes.
Yep, so obviously the use of sort of moving towards these PaaS platforms, or platform as a service, it enables standard interaction points with the framework. So that's just a standard place, in this case for OpenShift, it's a Git solution where a dev can drop their application artifact into the framework and just have it spun up in a standardized manner. And also standard consumption points, so effectively OpenShift's able to provide a HA solution by balancing traffic over multiple gears. Yeah, touch most of those points, just push ahead.
So the play here is, this is our solution 5. The play here is we still need to manage these PaaS platforms. Now, whether it be OpenShift or like a SmartOS or a Docker platform, whatever, like we still need the same governance compliance, right? So essentially, we're now looking at this kind of land. So we're looking at a land where Puppet is now the tool set that's in our little tool belt, which is managing the compute infrastructure in which OpenShift is deployed, right? And I know we've used OpenShift here, could have made it a little bit more generic, but just as an example, right? And then the business will drop apps into OpenShift, right? And they can put apps in there all day long, and we don't actually necessarily care what's going on. It's their responsibility to manage those apps. All we need to do is make sure that the platform, the PaaS platform itself, is scaled. Now, the next trick is, so let's put all of the slides together we presented.
I think, just to add there, I think a key piece on this as well is, traditional IT is getting moved out of the way. So rather than taking months to provision a server, you're looking at these standardized compute platforms or containers for these application artifacts where the customer doesn't need to request hardware. They simply get given an endpoint that's dynamically available, and by having that endpoint, they can readily consume and consume the platform for the deployment of their application.
Cool. So referencing the solution 1, there's no reason why we can't do this now, right? We can't globally distribute these PaaS platforms across 2 global regions, right? And have our central Puppet multi-master setup administering both regions simultaneously. So this is like phase 1. There's no reason we can't do this. We've already deployed this across many applications, across many sites. The next iteration of that, of course, so this is basically Puppet plus Autoscale Broker plus global distribution. Because we also have interfaced Puppet against multiple clouds previously by uplifting CloudPack, there's no reason we couldn't actually do this now. Not only are we globally distributed, but we can now leverage the APIs from multiple cloud providers to balance out apps between regions and within those regions between multi-cloud, right? So that's like the holy grail of application delivery is it's extremely redundant at that point, right? So we're not leveraging just one cloud provider and we're not leveraging just one global region. The natural extension of that, of course, is that that could also be in the mix, right? Since we've already standardized our compute platforms, there's no reason we couldn't apply that standardization to our data center at the same time in order to have our applications that are running in these PaaS frameworks still talking back to our physical data centers. Cool? Right, so that pretty much concludes. I guess we're open for questions at this point now. We'll talk about that. Perhaps we will open source the broker. I don't see any reason why not. If there's community demand to open source the broker, then we will open source the broker.
Just a question. So when you have different applications and they're all kind of trying to override one on top of another for capacity, and if you've got limited amount of money that you want to spend on EC2s and so on, how is that managed? Or
Yeah, so the question is like how you do cost control and cost mitigation, with these auto-scaling transient compute resources. So the first thing is there's a number of levers you can leverage within Amazon. So the first one is every auto-scale group has a minimum and max number, which obviously, when you do your planning and when you assess what the application is going to do, you would feed back to the business what's the maximum amount of money you're willing to spend per hour to run this application. So there are hard limits that the auto-scale groups will work within. The second thing is that these PaaS platforms are extremely efficient at managing the application across multiple instances. So because you just drop your application into said PaaS platform, the PaaS platform will then distribute your app amongst multiple instances. So you've kind of already hedged your bets and you've already hedged your load amongst that PaaS framework. But the cost control stuff's a very big one. Tagging's a huge part of that at Amazon. Again, like if you want more information, the Puppet user group, the Amazon user group's a great place for that. But the min-max scaling limits are the primary vehicle to control your application just scaling forever and going nuts and spending too much money.
one more question?
Yeah. How do you manage, since it's tightly coupled between the AWS API and your broker, how do you manage changes in the AWS?
We haven't had to do yet.
Utilising the sort of the Amazon SQL service in this case, being sort of a standardised, somewhat standardised messaging service, uplift to the broker itself to pull these messages down should be, I wouldn't see,
It shouldn't change.
Realistically, it shouldn't change, definitely. So.
But the point is if Puppet changes their API, then we'll have to change the broker. Yeah, like valid point, right? It's the same problem for every plugin / agent / whatever. Yeah. Nice. Cool. Thanks, guys. We appreciate it.
That's right.